Hello everyone, welcome back to CST Academy. In today's video, we will be demonstrating our server-side template injection pen testing tool in its controlled lab environment. So we'll start by explaining what is actually SSTI. Full form is server-side template injection, and how SSTI map, the tool works. This demonstration is strictly for educational and authorized testing purpose only. So let's get started. So let's quickly understand what is SSTI actually. It is a web application vulnerability that occurs when a user input is unsafely embedded into server-side template engines and the server fails to properly validate or sanitize the input. The attacker might be able to execute template expressions and can also do and have access to sensitive data or even in remote code execution, which is dependent on the template engine and the configuration of the server. So now we have a basic understanding of what is SSTI. So we have already set up an vulnerable web application here in a local machine for you guys. So as we can see here, the application is a profile page which sends an update to the server regarding the profile via a post request. So now we here intercept the request via burp suit and confirm that it is a post request. So we can see here that the request which get has a method of post request, and there are parameters, username, bio, location, vulnerable field, which we have intentionally put there. Okay, so we have a very nice tool which is an SSTI map. Okay, so in this tool I can show you that by giving a parameter by -u a flag and writing the URL of that application, here we have it is on local, so we will use that. Okay, and then after we put a parameter -d, which is the value of that parameters, that this is the parameters you need to take. Okay, so this is the vulnerable field. We have already given it a very intentionally, and we can give this command to SSTIMap. Now here you can see that it is testing for all the types of variations in different type of engines which is in that application. Okay, so like it's giving out a lot of, it is checking all the parameters which we have given there. And see here, we have seen a body parameter which is known as vulnerable field. It is using engine Jinja 2, and its injection point is there also mentioned. And it is, we clearly shows that shell command execution is also, like we can see here, we can what all capabilities it can do. So we rerun the same command just for an example for you guys, so that we don't have full again testing on the parameters. We'll just use the vulnerable parameter, vulnerable underscore field, for you guys, when we will use a command as -os shell, which will give us an interactive shell to that application. See here, we have already done it, and the commands of the operating system we can try. See, we have done ls, it gave us the interactive shell to that application. Because why? Because it was a vulnerable application. You can see UMI, it is a root, because it is a local machine, ID, GUID, we can test it in a lot of places. Okay, so here is a like a basic, very basic vulnerability we can check here. SSTIMap is a very, so now just let's quickly look at the impact what it is doing, and how we are gonna fix it. So just to give you another overview, that this SSTI vulnerability can only have an attacker to execute server-side codes, read sensitive files, access secrets like API keys or database credentials also in that server. And in some of the cases, it completely take over the server. That is also called a remote code execution we can do on that server. Okay, so to prevent this, never render user input as a template. That is the first and the foremost prevention technique. And then always treat user input as a plain data, and keep your template engines updated till the date. Okay, don't use betas, just try to keep them updated to the latest one. And you can use sandboxing also, or restricted executions also, wherever it's available. We can have template engines and the frameworks wherever it is possible, have validations and sanitizing also user input wherever possible. Don't directly treat the user input as a data, and specifically not as a template code ever. Okay, and after applying this fix, test the same payloads again, which we have tested earlier and given us the vulnerability or the tools which we have used, even if they are displayed as a normal text instead of being executed. Okay. And SSTI map also no longer detects that vulnerability. Then you have successfully fixed this issue. So guys, that's it for this video. See you in the next.